Hello students, welcome to Educate. We are going to do numericals on the chapter Oscillations of class 11 physics. So let's do first question. First question says, which of the following examples represent periodic motion? So, sorry. First one says, a swimmer completing one return trip from one bank of a river to the other bank. So this will not be periodic motion, right? Now, second case, a freely suspended bar magnet displaced from its north-south direction and released. It will oscillate periodically provided some external resistive forces are absent. And next one is a hydrogen molecule rotating about its center of mass. It will also be periodic. And last one is an arrow released from a bow. It will not be periodic. So you have understood. So two cases are there in which it will be periodic. So a freely suspended bar magnet displaced from its north-south direction and is released. So it will move to and fro and hence it will be periodic. And this case, a hydrogen molecule rotating about its center of mass. Now, next question. What is next question? Next question says, which of the following examples represent nearly simple harmonic motion and which represents periodic but not simple harmonic motion? So, the first case says the rotation of Earth about its orbit, about its axis. So, is it periodic? So, here it will be periodic, but it will not be simple harmonic. Second case is motion of an oscillating mercury column in a U-tube. Of course, it will be periodic and it will be simple harmonic. Then motion of a ball bearing inside a smooth curved ball when released from a point slightly above the lowermost point. So it will be simple harmonic. And general vibrations of a polyatomic molecules about its equilibrium position. So it can be periodic but not simple harmonic. So you have understood these cases. Now let's see some graphs and we have to tell whether they are periodic. If periodic, then what is time period? So here it is not periodic, it's not repeated. Here it is periodic. So if you observe the distance between peak and peak, so you will find 2 seconds. So you can say its time period will be 2 seconds. Here it is not periodic. Here it is periodic. Right? So up to here, there is no problem. Now, we are going to see next thing. There are some more questions. Okay. Which of the following functions of time represent a simple harmonic, periodic but not simple harmonic, non-periodic motion? Give period for each case of periodic motion. Omega is any positive constant. So here what we have to do, if you remember, sine function and cosine functions are considered to be periodic. So here the first function is made up of sine and cosine. So it will be periodic. we can also convert it into single form, like we are given sine omega t. So we are given sine omega t minus cos omega t, right? So one thing we can do, we write here 1 upon root 2 and we multiply each term by root 2 and root 2, and then we can write it further 1 upon root 2, and then this can be written as sine omega t into cos pi by 4 minus cos omega t into sine pi by 4, right? So this will become 1 upon root 2 sine omega t minus pi by 4. So here omega equal to 2 pi by t. So we have to find out what is time period, because question says give period in each case. So here period will be, this will be angle omega t minus pi by 4. This will be phase. So we don't have to find phase, we don't have to express it, it's okay. So here our concern is omega equal to 2 pi by t, or t equal to 2 pi by omega. This is first case. Sine cube omega t. Here, even if we convert it into single power, it will not be, here the case is simple harmonic, so it will not be simple harmonic. So we can see different cases. So let's convert it into single power. We are given sine cube omega t. If you remember, sine 3 theta, sine 3 omega t, if we write 3 sine omega t minus 4 sine cube omega t. Here our concern is to find sine cube omega t. So we can take this 3 sine 3 omega t to RHS, and we can divide by 1 by 4. So we will get sine cube omega t equal to 1 by 4 of 3 sine omega t minus sine 3 omega t. Correct? So these are separately periodic, but they will not represent simple harmonic motion. Here, if we want to find out period, so omega equal to 2 pi by t, from where we get t equal to 2 pi by omega. Similarly here, so it will be, in this case time period will be just 1 by 3 of original time period, whatever this 2 pi by omega, right? So we can write it t dash equal to 1 by 3t. Next question here, this is 3 cos pi by 4 minus 2 omega t. This will represent periodic motion plus so next part is 3 cos pi by 4 minus 2 omega t. So 3 cos pi by 4 minus 2 omega t. So we can take minus sign before 3 cos, if we write minus sign here, 2 omega t minus pi by 4. and sine, this sine will get absorbed. So 3 cos 2 omega t plus minus pi by 4. So this is periodic. This will also represent simple harmonic motion, and the time period will be just half of the period. Very simple rule is there to find time period. Suppose you are given sine omega t. So here time period will be t equal to 2 pi by omega, right? If here some number is given like sine n omega t, in that case time period will be 2 pi by n omega. So that thing we have to, right? We have to use this concept. So wherever it occurs, you can easily tell in terms of this t if you want to write. So this will become t upon n, right? So you can easily tell here also. What do you observe? Cos omega t, cos 3 omega t, cos 5 omega t separately, they are representing simple harmonic motion, but in combined way they will not represent. Next one is exponential function. It will never repeat, and here 1 plus omega t plus omega square t square will be monotonic function of increasing nature, so it will never repeat. Correct? So you have understood this question. Let's continue with the next question. Next question says, a particle is in linear simple harmonic motion between points A and B 10 centimeter apart. So we take this is A, this is B, and separation is 10. This is say 0. Now here minus 5 centimeter, this is plus 5 centimeter. So total distance will be 10 centimeter, right? And here situation is, now a particle is in simple linear simple harmonic motion between points A and B 10 centimeter apart. Take the direction from A to B as positive. So if you are moving in this direction, it will be positive. Take the direction from A to B as a positive direction and give the signs of velocity, acceleration and force on the particle when it is at the end point. Suppose this is case 1, so we can say here we write point, right? Then we need what all is needed: velocity, acceleration and force. Velocity, acceleration and force, right? So let's take different points at the end A. Here, when object is here, then what happens? Its velocity will be 0, right? But acceleration will be there. Here, what is our question? Question is asking, we have to tell the sign, right? So we can easily tell. So velocity will be 0. What will be acceleration? It is going toward this positive direction. So acceleration will be positive and force will also be positive because F equal to ma. Now what is second case? I at the point B here. So velocity will be 0 and situation will be just negative. So acceleration will be negative, force will be negative, right? Now next case says at the midpoint of AB going towards A, when it is here, so I at O, let's write, then in this case velocity will be maximum and other things means displacement will be 0. This is 0, this is 0. So velocity will be maximum, but it will be negative, right? Now next case says at 2 centimeter from B going toward A. 2 centimeter from B going toward A. It is moving in this direction. In this case, what happens? All three quantities will be negative. So here let's write this point as D. So at D, this will be negative. Course here acceleration will be negative, and this will also be negative. Then comes next point at 3 centimeter from A going toward B. At 3 centimeters, suppose this is at point E. So at E, situation will get just reversed. Here we have seen all three were negative. Here all three will be positive. And last case, at 4 centimeter away from B going toward A. Again, it's here 4 centimeter away from B. So here, what will be the case? Going toward, once again, let's read the question. At 4 centimeter away from B going toward A. It's going toward A. So here, answer will be velocity will be negative and others two will be positive. So negative, positive, positive. So this is the case. We are going to analyze next question. What is next question? It says, which of the following relationship between the acceleration and a displacement of a particle involves simple harmonic motion? So if you remember the basic relation when we started, like x equal to a cos omega t, then we write dx upon dt, which gives minus a omega sine omega t, and when we write acceleration, so for this we write minus a omega square cos omega t, or a is equal to minus omega square x. So what do we observe? A proportional to x, right? So here in our question, if we here put a constant a equal to minus kx. So this situation is satisfied in this case, in case of C, where a is given as minus 10x. So here k will have value 10, right? So this is the case. Let's go to next question. What is next question? Next question says, the motion of a particle executing simple harmonic motion is described by the displacement function x t a cos omega t. We are given x equal to a cos omega t plus phi, right? And some condition is given. When t equal to 0, x equal to 1 centimeter. T equal to 0, x equal to 1 cm. So we write it here, 1 equal to a cos phi. This is equation number 1. Now, then question says, the initial velocity is omega centimeter per second. So to find velocity, we differentiate it. Dx upon dt is equal to minus a omega sine omega t plus phi. Again, we are given here when t equal to 0, velocity is omega. At t equal to 0, v is given as omega. So we can put this value here. So omega equal to minus a omega sine phi, or we can say minus 1 equal to a sine phi. This is equation number 2. If we square the two equations and add, then what do we get? We get a square equal to 1 square plus 1 square which gives a equal to root 2. Now we have to find out the value of phi. So here we divide equation 2 by equation 1. So we get tan phi is equal to minus 1. Now we have to choose the value that satisfies this equation. So what can be the value of phi? So in this case, phi will be either 3 pi by 4 or 7 pi by 4. So phi equal to 3 pi by 4 or 7 pi by 4, right? So this is first case. Now here again another condition is given that if x is written as b sine omega t plus alpha, in that case what will be the case, assuming that conditions remain same. So let's see this situation also. In this case, what happens? We are given x equal to b sine omega t plus alpha. Here x is given as 1, b is b sine t is 0. So sine alpha, equation number 1. And again same condition. So velocity we find from here. Velocity will be b omega and then cos omega t plus alpha. Condition is v is given as omega, t is 0. So after putting this value, we get omega equal to omega into b cos alpha, or we get 1 equal to b cos alpha, equation number 2. Again we square and add, squaring and adding. So what do we get? We get b equal to root 2. Then again we divide the two equations. So tan alpha will be 1. So what are the possible values of alpha in this case? So either pi by 4 or 5 pi by 4. Alpha equal to pi by 4 or 5 pi by 4. Right? So I think you have understood. Now let's take next question. Next question says, a spring balance has a scale that reads 0 to 50 kg. The length of the scale is 20 centimeter. A body is suspended from this balance when displaced and released, oscillates with a period of 0.6 second. What is the weight of the body? This is a good question. So first of all, we have to find out spring constant. So you know F equal to minus kx, right? And F can be taken as mg. M is 50. Then we can evaluate. So let's write its value in terms of magnitude. So for taking magnitude, we will just write F equal to kx. So F is mg. M is 50. G we can take either 9.8. So that will be easier. 9.8 equal to k times x is displacement is given as 20 centimeter. So we can write in terms of meter 0.2, and then we can evaluate. So just we divide, this will become 49 into 50. 49 into 50 will be 2450. 2450 Newton per meter. We have got the value of k. Now thing is simple. We have to find out what is time period. So first of all, let's put the equation of time period, 2 pi root m upon k, right? Here our concern is to find m. So first let's square it. T square equal to 4 pi square into m divided by k, which gives m equals t square into k divided by 4 pi square. So let's put the values. M equal to t square. Time period is given as 0.6 square into spring constant we have found as 2450 and divided by 4 times pi square is almost 9.8. We can evaluate it. So it will come out to be 22.36 kg. Now we need weight, and we know weight is mg. So we put the values. M is 22.36 into g is 9.8. So we can evaluate it, which will come out to be 219.13 Newton. So I think you have understood. Now, here there is one more question. A spring having with a spring constant this much is mounted on a horizontal table as shown in the figure. A mass of 3 kg is attached to the free end of the spring. The mass is then pulled sideways to distance of 2 cm and released. Determine the frequency of oscillation, maximum acceleration of the mass, and the maximum speed of the mass. So let's find out. So here we are given spring constant K equal to 1200 Newton per meter, and mass is given kg, and here display distance 2 centimeters, so x is 2 centimeter. What more? Nothing. Now we have to find out frequency. So nu is given by 1 upon 2 pi and then square root of k upon m. We can put the values 1 upon 2 into 3.14 square root of k. K is 1200 divided by 3. So it will give 20, and then 20 divided by this much. So it will give 3.2 hertz. So it is simple, right? Then second part says the frequency of oscillation we have found, maximum acceleration. So acceleration maximum value. So maximum acceleration will be omega square times amplitude. Omega square. So we can find omega from here. 2 pi into nu, right? So 2 into 3.14 into 3.2. So that will be value of omega. That will be around 20 per second, right? 20 second minus 1. And here we have got the value of omega. So A maximum can be found omega square times A. So that is 20 square times amplitude. Amplitude is given 2 centimeters. So 2 into 10 to the power minus 2. And we can evaluate it. So it will become 8 meter per second square, right? And then last case is we have to find out V maximum. So maximum velocity is equal to omega times A. Omega we have got as 20 and amplitude is as 2 into 10 to the power minus 2. So we can simplify it to get 0.4 meter per second. 0.4 meter per second. So this is answer to question number 13.9. So this is all in this lecture. We will continue with other questions in next lecture. Thank you for watching. Team Educate.